Hey guys, I want to go over chapter 12 just briefly. I do the best I can. Mainly want to show you the problems so you can see how to do the problems for 12 and 15. But the real thing that we're introducing here in chapter 12 is the ANOVA and post hoc tests. And that's when you're looking for correlations between more than just two treatments. For two treatments, we learned and we've used the t-test. But now if we're going to use more than three treatments, like gender, age, tenure, that's more than two, we've got to move to ANOVA now. And so that's why we're learning this. So the steps are spelled out here. There's a lot of new terms you're going to see. The main one being analysis of sum squared, the SS. That's the sum of squares. So I'm going to just go right into the problems so that way you can know how to do it for the homework. 2 and 3 is just short answer. You can look at those and answer. I think I already gave you one with my description of the intro to the chapter. But chapter 4, we're going to calculate sum of squares for the total, the sum of squares for between, and the sum of squares for within for the following. So the total means just the sum of squares for all the treatments 1, 2, and 3 together, and then between is going to be the sum of squares between the various treatments, and then the sum of squares within is going to be the sum of squares for within treatment 1, separately within treatment 2, and then within treatment 3. You'll read all about that in the chapter, but really I'm just here to help you go through the math. Let's get this book. So they give you this data here, treatment 1, 2, and 3. They give you the N for each. That means the sample in each. So the samples were the same size, 10. That means our grand total sample was 30. That's the large N, equals 30. The T is our total of X. Why they call it capital T, I forget. Maybe because T for treatment. But anyway, the total of all the N's added up to 10, added up to 20, and then added up to 30 in the third treatment. And then G over here is the total of all those. It's like your grand total. And then your sum of squares for treatment 1 is 27, sum of squares is 16 for 2, and 23 for 3. And then they've already calculated a formula here. The sum of x squares is 206. So to do the calculation, what I've done is I've made this little cheat sheet for myself. It's really what they have in the chapter. They have all these formulas, but they're scattered over 10 or 12 pages, so I just put them all neatly in one. And these are the 9 steps, 1 through 9, to calculate the F ratio. So you can pause here and copy them down or whatever. Forgive my handwriting. That's just how it is. So to do any of find your F ratio, you need to first of all get your sum of squares total for all N, and there's the formula right there. You can either use the sum of x squared minus the sum of x squared over N, or you can replace this numerator with G, and you can do it that way, okay? Use my pen instead of my finger. Then you need to get the sum of squares within, which is just equal to the sum of squares in each treatment. That is not plus 7 or T7, that's my shorthand for treatment. Sum of squares between equals the sum of squares total minus the sum of squares in each. I bet you that's supposed to be within. Yes, it's supposed to be within. And then you get your degrees of freedom. The total degrees of freedom is your total number of N's minus 1. Degrees of freedom from within is your summation of your little n minus 1 for each treatment, right here. The sum of degrees of freedom in each treatment. And then degrees of freedom between is just the number of treatments you have minus 1. In this case, we have 3 treatments, so it would be 2 would be the answer for problem 4. Anyway, then you have to multiply your between variance and your within variance. And here's the formula for, this is the notation for between variance. So the ms between is equal to s squared between, which is equal to the sum of the squares between over your degrees of freedom between, and on and on. You can look at the rest. But these are the formulas that you will need. So getting into the problems, I've answered 1 and 2, I think, in my description of the chapter, but here's where we're going to get the problem. So if we look at problem 4, I just kind of rewrote it here and started doing the calculations. So really, here's the calculations. Right there. And you'll notice that it's asking us to calculate the sum of squares within, which is 60, the sum of squares between, which ends up being 26, and the sum of squares total. I actually calculated the sum of squares total second, so I came up with 86, and that's how I was able to do sum of squares between. So in order, I did sum of squares within, which is the first one. Then I calculated sum of squares total, and then from that I got 86, and then I was able to then do sum of squares between. But that's the way you would do it. And then for number 6, what does that say? A researcher reports an F ratio with the degrees of freedom between of 2 and degrees of freedom between of 30 for an independent measure. Measures for ANOVA. How many treatment conditions were compared and how many subjects participated? So here's a way to do that. Right here, part A, number of treatment conditions was 3, and here's how I got it. All we needed were degrees of freedom within, which is k minus 1, and they gave us the information that degrees of freedom equal 2. So if you just solve for k, you get 3. And then the last one, the number of subjects who participated, is going to be the degrees of freedom, which is 30, but then you have to add back 1 for every treatment. So that'd be 33. This answer, I'm not 100% on, 33. It could be 32, but I'm pretty sure that's the correct answer. And because they're asking for degrees of freedom, right? Between, isn't that what they asked? No, they gave us the degrees of freedom. They said how many subjects participated. So in essence, we're kind of working backwards and we're trying to find the G number, or the total like in this one, another one we had G60, that was just the total. So I'm pretty sure that's the right answer. Then number 10 was kind of tricky, I'll tell you that. I'm going to put it right here and let you just kind of see the whole page. You can pause it. So they gave us the 58, they gave us the total number here, the sum of squared total. They gave us none of these, and then they gave us the MS within of 2. We had to solve for all of the between treatments, and we had to solve for F, and then the within treatments, these two and this one. We had to solve for all those. And the hint was to start with your degrees of freedom. So that's just what I did. So starting with, we knew what n, the little n was because they gave it to us. And since there was 4 treatments, it stands to reason that 6 times 4, 24, that's the total number of scores or treatment, the total, the G, or the grand total. So that's all I did for n. Then I came down and said, okay, degrees of freedom between is k minus 1, which they already, degrees of freedom, oh, yeah, degrees of freedom is k minus 1. And k, as we remember, is just the number of treatments, 1, 2, 3, 4. So it was 4, minus 1, and that's 3. So then I went down here and did the degrees of freedom within, which is just the sum of your n minus 1, all 4 of them. So we know that n was 6, so 6 minus 1 is 5, so they were all 5, and we had 4 of them, so it was 20. Degrees of freedom total is your total n minus 1. 23. You know what? Now I'm questioning number 6. But anyway, that's just a small piece of that problem. Okay, so now the fifth step is the ms within, which is just equal to the sum of squares within. Oh, anyway, so the 3, the 20, and the 23, I ended up just putting them in here. Okay, that's where they go, because that's the degrees of freedom. Then I'm looking at, I solve for ms within, so it's the, because we have, why did I do that? Oh, because I have my degrees of freedom. Okay, yes, we have the ms within of 2 within. So if ms within equals sum of squares within over the degrees of freedom within, then you can just do algebra and fill in the gaps. So they gave us the 2, and we solved for the 20 up here, so that we left us with x. So x equals 40, which equals the sum of squares within. So we'll put that right there. So then I went on to the sum of squares between, because we have our total sum of squares, which is 58, and now we just solve for the within amount, so 18. And that's what we put up here. So now we've got all these done. Now we just need a couple more. The ms between is your sum of squares between, which we've calculated already at 18, and the degrees of freedom between, which we calculated at 3, 6. So 6 goes up there. And the last thing is the f. So it's the ms between over the ms within. 6 divided by 2 is 3. So that's your f. That's all they wanted to know. They didn't want to go any further than that as far as if this f score indicates a significant change or not, or a significant correlation, I'm sorry, or not. They just wanted the number, so there it is. Okay, yeah, wow. So then we move to chapter 15. And 15 is I did not read the whole thing, but they're introducing the Pearson correlation, which we've seen in all the previous classes. We've seen them in a bunch of lit reviews. I think when they're doing a lot of what's the word? Meta-analysis. I think they use that. And so Pearson correlation. Well, I thought they defined it. I guess you can look at the definition. But really, I'm just going to go through the problems. So they were very quick. They're very quick. And it was just number 2 and 4. What information is provided by the numerical value? So we've learned that it's the magnitude, right? For example, 0.2 might be considered not such a high correlation, but 0.8, 0.9 are considered high correlations, whether it's positive or negative. So I think that's what I put on my answer. The numerical value represents the magnitude of the correlation, where 0 is weak, or no relation actually, and 1 is a perfect relation. I thought about using the word strong or strength, the strength of the correlation, but I think that's wrong, I guess, if you're looking at negative. So I just decided to use magnitude. So the problem is pretty simple math. It's just getting through it. Number 4, it's telling you to calculate the SP. And the SP is simply the sum of the products of the deviations. And there's your set of X and Y. So all you've got to do, and I'm surprised there was decimals here. Usually the problems they give us, don't go into that. They usually use whole numbers, but here we had decimals. So If I'm wrong, I'm wrong. But I think all we do is we add everything up and get the mean, which is 1.33. All of this adds to 8. Divided by the total number we have is 6. That's 133. And then for y, we do the same thing. The total is 15. We have 6 numbers here, so it's 2.5. The next step will be to look at your x minus your mean. So you do that with each one. So 0 minus 1.33 is negative 133. 1 minus 1.33 is negative 0.33. And on and on. We're just doing this minus the mean. Then the next thing we do is y minus the mean of y. So y minus the mean of y. 4 minus 2.5 is 1.5. 1 minus 2.5 is 1.5, and on. So now you have the x minus your mean and y minus mean all separate. And so then all that we have to do is multiply them. Negative 1.33 times 1.5 is negative 2. That's a scratch out. Negative 0.33 times negative 1.5 is 0.5, but it's a positive because negative times negative. And you do that all the way down, and I get negative 10, and that's your SP. That's what they asked for. I'm a little unsure because I didn't read the chapter completely if this can be a negative number. I hope it can be because that's what I came up with. That's it. That's problem 4. So I hope this helps. I know I didn't explain a lot in the book. It's a lot of reading, and it just boils down to these few ideas. So I thought I'd get right into the problems. Call me or ping me or text me or whatever if you have any questions. Bye.